machine systems dedicated to read and handling internet people. So this is written by Robert Tapino and one of his members. My guide is Mehul sir and Professor Agarwal. So these are the contents that I am going to cover in today's seminar. So our project title for the final year is Aura, that is Adaptive Universal Resource for Accessibility, and my project domain includes human computer interaction, that is HCI, artificial intelligence AI, and machine learning ML, with basically more on the deep learning and CNN models. These are my team members, Rishikesh, Krishna, Harshada, and me. So the motivation behind this topic is, as per some of the reports, 97% of about 1 million of websites are failed to meet the basic guidelines that make inaccessible to people with disabilities. So while choosing this stream, we have the motto that we are learning this technology to implement this technology somewhere that can help society to get some better and efficient results. So for implementing this, we have worked on this topic, and this true accessibility means not creating a world where there is no lift behind. So we have to implement that our motto, and for that's why we chosen this topic. So what our problem statement is? So we are making an extension that have different features, and when user will enable this extension, the people with different disabilities like visually impaired, audibly impaired, who are not able to move properly, those can use any website easily. So the aim of the project is to develop a browser extension that ensures universal web accessibility, that everyone with any disability can access any website or any application. So we have made 4 features till now, which are the color bright and friendly, eye tracking, real-time subtitles, and voice command navigation. So there are color bright features. In India also, 800 people, in 100 people there are almost 80 to 100 people are color bright. So for that people, for now there is no like color bright mode or something by which they can view our websites, normal websites properly. So we are developing the colorblind mode by which they can convert the whole website theme to which they will be shown as normal. Next one is the eye tracking. So the people who are not able to move it properly, so they can keep this eye tracking. So by eye tracking, they will be able to navigate throughout the apps and the websites. Next one is the real-time subtitles. So which are the deaf people or who are not able to listen properly, for them we are making the real-time subtitles, that for the video or for any multimedia we are providing the real-time subtitles which will be synchronized with timestamps. Next one is the voice command navigation. So voice command navigation is browsing and accessing the whole browser and getting response from them through the voice navigations. So my team members, Rishikesh has covered the colorblind part already. Krishna will be covering eye tracking. I am presenting the subtitle synchronization, and Harshada will be covering the voice navigation part. So let's dive into my topic. So first, my research paper, authors have distributed it in 3 main parts. They have 3 main goals. First one is the subtitle synchronization, that is adjusting the timeline. So now what happens when in the YouTube or where we can see, like if I say hello sir at 10 seconds, the subtitles are generated or seen at 0.15 seconds. So this is what we want to make it accurate. Like if I am saying at 10 seconds, the subtitles should also occur at 10 seconds only. Next one is the timestamp refinement. So many times it happens, like on some words we stress more, on some words we just keep some letters and go fast. So what happens, those words, some words keep moving on the subtitle for very long and some are just going out. So we want to make the timestamp refinement that every letter is at the time, at the caption, so that everyone can watch it properly and understand properly. Next one is the optimal positioning. Many times it happens that the subtitles are coming on the screen when there is something important on that picture, and some subtitles are overriding or getting up to on it. So like if we are taking an interview of a person, so their nameplates are generally here, and subtitles also come at the bottom of video. So those are overriding, that clashing with the nameplates. So for that purpose, they are giving the optimal positioning. So like in this the CNN will be implemented. Let's see another one. And next one is the evaluation and accuracy. So this is tested on 30 French TVs with 90 and gated the 90% accuracy. Also the 70 people from age group 18 to 67 had used this feature according to authors, and they have given that 93.1% accuracy they got through their testimonials. So this is the literature. In late 1800, the main concept of this subtitles and this thing has come. In 1782, the first acoustic mechanical speech machine was developed. In 1879, Thomas Alva Edison invented the first dictation machine, and that's how the evolution goes on. This is how this picture I have taken from the media. And in 2008, Google launches the microphone that bringing speech, like we have that microphone on Google slide, and we started talking. From that time, the subtitles got the another level. Like the development goes from year to year. And then in 2011, Apple also announced a series. So this also gives a good boost on speed. So these are some literature related to this. So first one is when textual and visual information join forces for multimedia retrieval. So in this, the study focuses on multimedia retrieval, like retrieving that audio or that subtitles from it, and the text-based retrieval. The problems in this one that text-based retrieval is limited and visual-based retrieval is very challenging because everyone's accent and everyone's languages are different. So the subtitles may not match speech exactly, but they preserve meaning, but they were not matching exactly. Next one was the audio and text synchronization for TV news. So for TV news subtitling based on automatic speech recognition. So in this proposed method was synchronized subtitles with TV news and using automatic speech recognition. So there are many ASR errors, and this model was not able to handle the background noise. So this was its main problem. And traditional subtitle synchronization in manual is quite time consuming. So it was able to reduce that human error, but it was not able to match the subtitles properly. And also the multilingual support was also faced. So this was not also the efficient one. Next one was the recursive algorithm for forced alignment of very long audio. So main problem is when there is very long audio, we have to break it down in many tokens. And for the long audio, there was very like high computational cost, and error propagation was also more. So that's why this was also not that much efficient, but they give a good breakthrough to research further. So these are the some previously developed toolkits which are for subtitles generation. First one is the Cell Align. So Cell Align is an open source tool for syncing speech with text, and it uses voice activity detection to segment audio without cutting words. So the main problem is when we have, we will see further also that if text is going to get into a list and we have to break down into some tokens or like in a part, but while doing this we have to make ensure that these tokens or parts are not breaking any words. Like if I am saying cat is going, so it should not, if I say that 4 words come in, so it will like CATR, then it doesn't making any sense. So the main part of the main thing on which Cell Align was this, that it was not cutting the words throughout and everything, and it applies ASR to recognize and align words. So using this ASR, it was aligning words. Next one was the hidden morpheme model, which was HMM, a probabilistic model that predicts speech as a sequence of phonemes. Like it was mapping what we have saved with the original phonemes in the database, and it uses state transitions, like we go from lower to upper bound, like we say lower sa, upper sa. So it was taking care of all those things, and then predicting using the phonemes. Next, but in this the problem was it works on some basic like some biased data sets. Like we have field name, it works on only them, but sometimes its prediction gets false. So that's why it was not efficient. Second one is the Culti toolkit. It is also an open source ASR framework which uses phonemes alignment and dynamic programming to improve accuracy. So Culti toolkit is one that covers the disadvantages of about two, and it is the combination microwaves. And these are our analog signals. Those are getting converted into digital point, and for that we are using the sound card, that is ADC. Next one is the feature extraction. Like now we had conversion is done. So what are main things are for us that are getting extracted. After that the acoustic model is getting. So in the acoustic model we are mapping that what we have derived with what our data set, like we are mapping with the right phenoms and we are converting it properly. Then next one is the language model. So in the language model it is getting aligned properly, and using the decoders the subtitles are getting generated. So in this system authors has covered that they require three major components. First one is the language model toolkit. For this here they use open source CMU Espinix system. So using this they are covering this. So in this they are dictating the text using the framework which is the CNN based. Next one is CMU takes audio from the target video and provides transcriptions with timestamps. So this is the main point that we are providing. They have provided the timestamps, and this the error rate was 35%, which is quite reducible. Next one is this accurately timestamps were identified in this point. Text detection framework based on the convolutional neural networks, it identifies the existing text in the video stream and adjusted subtitle positioning on the video. So this is the workflow. First we are taking the multimedia file. Author are taking the multimedia file. Then audio documented. There are two types, like audio document. First the closed captions are provided. So closed caption is something that the transcript of video is given by the human manually. Next audio document, video document. Then they are pre-processed and CC are positioned based on that and aligned on our video. When the audio document is taken, the automatic speech recognition, which is ASR, is taken and it is applied on model language model. After that the text transcript is generated, and then the text processing happens. So in text processing the main four parts happen. One is the token extraction. So token extraction is breaking the whole script into small identified parts. Next one is the common words removal, like all and nothing. These types of common words are removed. Next one is the accent removal, like making it uniform for all accents. Next one is the token documenting. So like if there is something like running, we convert it to run, and by taking correspondence of these ASR words, token, we convert it to anchor words. So let's see what these anchor words mean. Next. So this is in this we are taking the closed captions and participate. So in this what is happening? We are computing the start time and end time for each token, and that from the human transcript also and from the ASR also, and then we are processing it using token extraction, common word removal, accent removal, and token stemming, which I have just explained. After establishing this correspondence, that is after giving it the start time and end time, the two lists are made. One for human closed caption, that is CC, and next one is for ASR. And in this, the duplicates that are both into are removed. And next one. So in this you can see that those who have the same timings, like in the same timing, those who have the word who have the same timing in both of them, that those words are extracted and others are deployed, and the final list is got. So let's understand this using this. So for example, this is the closed caption list, like the sheep is selling. So they have given that this phrase is starting at 2 seconds and ending at 4 seconds. They have given this for all 3 phases, and these are the ASR transcripts that are automatically generated. And in that they are not working on sheep, but they are working on tokens, so separate words. Sheep selling rough waters post. So what is happening? Like here it is starting from 2 to 4, and here also the sheep is from 2 to 4. Like in that timestamp only, so anchor words are written. So these 5 words are anchor words: sheep selling rough waters and post. Now this phrase inherits timestamp from anchor words. In P1 sheep, here it is starting from 2.1, so it will get that point. And so first anchor word was next was selling. So selling it has the 3.8 end time. So overall phrase will start at 2.1 and end at 3.8. So for these all three phases we have done this. If no anchor word is found, using this formula we will get it starting at 8 points. Now here we get, now if the bonus time is left, like we have the some time before and some time after, we are getting it like expected time minus actual length time upon 2, and by getting this we are getting the bonus time. And if something bonus time is there, we are expanding it like for left expansion. Our time which we are aligning is equal to its time minus bonus time. And for right, we are just adding the bonus time. So by calculating all this, for P3 bonus time is 0.85 seconds, and new start time, by doing all these calculations, the new start time is 6.65 and new end time is 8.65, which was before 6.8 and 8.5. So we are getting the final subtitle timing efficiently using our algorithm. So this is what I just explained here. This is the mathematical foundation which I calculated here. This is the performance matrix which I have told earlier also. It gives 93.1% accuracy for the human testimonials and 90% accuracy technically. Next one. So technology used in this are mainly NLP, natural language processing, and synchronization algorithms. ASR, that is automated speech recognition, machine learning, computer vision, and text alignment algorithms. Applications are live broadcast subtitling, video streaming services, hearing impaired accessibility, multilingual content adaptation, legal language transcription, educational videos. Future prospects for this are multimodal subtitle positioning, large data set evaluation, reduce synchronization delay. These are the some of references that also are used by researching on this topic. And in the conclusion, I will say that this algorithm is quite efficient, but it is taking some human abstracts in considering like closed captions. So when we are implementing it, we are trying to just cancel this human interfere in it and making it totally automated. Next one is it achieves over 90% accuracy, which is quite good. But while implementing, we will try to make it more accurate. Next one is the AI-driven subtitle generation and speaker recognition can enhance automation and accuracy. Dynamic subtitle placement can prevent overlap with on-screen text and keep the important text as it is. Expanding user testing and hearing impaired individuals can refine accessibility. Like while developing this, doing the testing on which audibly impaired people is important because they will give us the right output. And AI speaker recognition and dynamic placement can improve automation, readability, and accessibility. Thank you.
Observations are mentioned by the authors. In the case of first type of document that we have considered, or closed captions, CC. So have they mentioned any observations, particularly in comparison with this ASR translation, which is I think second type of document. Audio speech recognition. Two, right? One CC and second ASR. So in closed captions and audio speech recognition, what specific observations have they mentioned?
So there are mainly three types of error they face. That first one is the group elimination. Like for some group errors they have faced misinterpretation. Like
basically group of words.
Group of words is getting misinterpreted. They have mentioned these also this and also misinterpretation. Like the video is wanting to say something different, but they misinterpret it, and sometimes repeated words occur, and sometimes also the words like one letter of the words get changed, and by that the whole meaning spelling errors.
And in ASR there are different types of errors.
Yeah. In ASR also there are three errors.
Homophone substitution, misinterpretation, and group errors. So is there any specific requirement for multimedia file?
Here they have not mentioned it like explicitly in research paper. They did not mention. But as per my research, the MP3 file
There should be like something like start time.
end time.
Threshold. Like
So in that CC they are mentioning the start time and end time. Closed caption.
How pre-processing is done? Is it required?
Yes, pre-processing is required. So in this, take that caption. So text processing is that token extraction. So in text pre-processing, four main steps are required. First is token extraction, that breaking that whole big sentence into small tokens. Next one is the common words removal, like the and or those words are removed. Next one is the accent removal, like making it uniform and understandable to computer and removing the all accents. And token stemming, like if there are the like running, then you are convert it to run. So which are commonly found in our database.
Any question from audience? Oh, okay. Very good.